Today we did lesson 10 of unit 6. We were tasked with finding out what quadratic expressions in standard and factored forms can reveal. So those of you that had the lesson already, what can we tell very easily from standard form? More than half of you have the lesson in the first hour. So when something's in standard form, what can we easily see from the standard form? X and Y, no, I wouldn't say both, but X and okay, so I know what you're saying though, like in the standard form, you could see the X squared really easily versus in factor form, it's probably not an X squared yet. But actually, we're talking about something else. Okay, so if it's a projectile motion problem, the starting height would be what letter? Starting height would be. Okay, so starting height, it would be the single number, and I know we're using the letters A, B, and C could all be numbers. All right, so your starting height is that single number. So in this case, in standard form, it'd be the C, the last one usually. And what's our starting height usually on a graph? The y-intercept. So when something's in standard form, you can clearly see the y-intercept. Even if it's not a projectile motion problem, that single number, say, I don't know, I'm just making a random one up. That single number is going to be my y-intercept. Without graphing, I know that. Okay, so that's what you can easily see from standard form. You can easily see the y-intercept. And then, of course, if it's a projectile motion problem, then you can easily see the velocity and you can easily see the effect of gravity. But the y-intercept is the major thing. From factored form, what can we easily see from that? So factored form is when you can multiply or distribute or FOIL or diagram. Those of you that had the lesson today, I wouldn't expect the others to know yet because they haven't. When something is in factor form, like here's a random example. What's gonna be something that I can see easily from this? The x-intercepts you can easily see when it's in factor form. What would be my x-intercepts of this random example I just did? Not 2, but boys, look at the screen. What would be my x-intercepts of this random factor form expression I made? -2 and a +1. I won't write it in coordinate form right now, but -2 and a +1. So what we were noticing in a series of a bunch of graphs and their equivalent equations, the x-intercepts happen to be like this number just with an opposite sign. That's what we noticed. You'll see why is that later on, but that's what we were noticing. So when it's in factor form, you can identify your x-intercepts or your zeros really easily, and we'll use examples of that. So I pulled up a random Quizlet, like I just went on Google, and I wanted it to help me practice identifying my zeros from the factored form. So even those of you that haven't had the lesson yet, now that I kind of gave you that little bit of information, it's going to be these numbers just with opposite symbols. So what's gonna be my x-intercepts of this function? 1 and 2. Well, positive, because in the equation, their negative is gonna be always the opposite. Do you see what I mean now? Okay, so here's the next one. Don't say it yet until I ask you. Oh, that one's kind of hard. Let me get that one. Go back to the beginning. Because right now, we're only looking at it if it is, in a form like this. So now, think in your head, what are my x-intercepts gonna be? What are my x-intercepts? 3 and -5. Think about it, don't say it yet. Using what we learned today, what will my x-intercepts be? Okay, good. Next one. We already did that one, I think. Okay, now, all we did today was when there is no number in front of the x. We'll see that in a different day. I don't want to overload you too much. But I know at least one of my x-intercepts will be the -6 that's here. I'll show you how to get the other one. And on another day. But that's basically what we learned. In standard form, you can easily see the y-intercept, it's always a single number. In factored form, you can clearly see the x-intercepts, it's always these numbers, just with opposite signs. So you have a practice to now practice those skills, and I know if you haven't had the lesson yet, that might be a little harder. But basically, here's your to-do list. Let me go back to it. Do I have a to-do list in here? I guess I don't. Maybe I put it in here because my 4th hour is having a sub later, so I put it in this list. So here's what you should do in order of priority. If you have not finished and resubmitted that coloring activity for multiplying polynomials, maybe make that your first priority, because it will be a grade in MATLAB and in algebra. Then go and try to get 80% or higher on that lesson time practice that goes with the learning targets we just went over. Then after that, next Friday is gonna be our binder check. You probably wanna make sure that you have all your notes up to date from the beginning of the unit till now. They're all in here if you need them. And then that's pretty much it. Make sure your other work is done. I feel like that would take you the whole time. Questions on anything? So feel free to ask as you go. I'll come to you. Call me over. 9 o'clock though, I'll have you start helping on the screen.
Lesson 10 practice number 6. A company sells a video game. If the price of the game in dollars is P, the company estimates that it'll sell 20,000 minus 500 P games, which expression represents the revenue in dollars from selling the games if the game is priced at $2. So remove anything that might be confusing about this problem and just think like in the real world. Revenue is what? It's money that you get from selling something. So I don't know, say you sold 3 video games at $10 each, well, then your revenue is $30 or something like that. You're multiplying by what the cost is and then by how many you're selling. So in this one, it is giving expressions for each. So it says that the price is P, that's going to be my cost. I'm going to multiply it by how many I'm selling, and it's giving an expression that they're using to estimate how many sold. So it'll be times the 20,000 minus 500 P. And then that should match one of them already. Which one does it match? Maybe just in a different order. The last one shows me multiplying the cost by how many are being bought. That's what gives us revenue.
I feel like on your test, they would probably actually distribute this. And then give you this expression for how much it is for the revenue, which you can now see as quadratic. But on our practices, they just kind of leave it as cost times how many sold. So good on that one? Okay, questions on any others from anything? Is it? Okay, so it's kind of 0.4 and 5. And 4, if you guys needed help with that one. So the area of each small square is 1 square centimeters, and it says what's the area of the shape in step 10. So anytime it's like a figure pattern, I want you to relate it to the number, like relate it to numbers rather than trying to figure out how it changes each step. Like it kind of looks like they're adding one on top and then adding a row and things like that. I would just relate it to numbers. So if each square is 1 square centimeters, that means my area for step 1 is 2. My area for step 2 is 7. My area for step 3 is 14. And we're wanting to get all the way to step 10. So are we seeing a pattern within the numbers at all? I would say that this one is probably a little bit hard. Think back to, because I'm not seeing that it's adding the same amount each time. I'm not seeing that it's multiplying the same amount each time. So it's probably gonna be quadratic in a way. So something with an x squared. And if you remember those lessons, like it was almost like we had the individual square and then we were adding something to it. So let me see if I have them. But in this one, I'm seeing like a single square could be 1 squared, which is 1, and then to get 2, I could add 1. The next perfect square, so if I think of like my list of perfect squares, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. In step 1, I have a 1 squared that I could do. In step 2, I could try 2 squared, which is 4, plus 3 could give me 7, so kind of seeing a little bit of a pattern. Let's see if we can see this one. 9 would be 3 squared. And then to get to 14, I'd be adding 5. So here's the pattern that I'm seeing. It's my perfect squares relating to the step. So we're squaring the step, and then it's like we're adding an extra 2 to what we had before, if that makes sense. So I think that in step 10, it will be 10 squared plus, let me figure out, I might have to consider higher. 5, 7, 9, 11, 13, 15, 19. So I think the number is gonna be 10 squared, which is 100, plus 19, which is 119. We'll see if it's right in a second. As far as the area in terms of n, I'd have to make it the step squared, but I don't know how to relate this next part. Like, I know it's counting by odds, like it's a different odd number each time, but I don't know how to relate that. Let me just keep looking up things then. Okay, so 119 for circles, right, I continue the pattern. For the area, it's giving me this expression. Which I don't think you will need to know for your test. But. That's the expression. Looks like they're doing the sub number plus 1 squared and then. Weird. All right, questions on this one? Questions on others? Be from anything, could be from the coloring sheet, anything that says. Next. On lesson 10. So let's see. Correct, so number 1 on today's practice. We have this quadratic function described by x minus 7 times x plus 3. And it says, without graphing, identify the x-intercepts, and it looks like it wants you to put them in coordinate form. And then it says, expand it down here, which really just means like FOIL, distribute, basically get the standard form to find your y-intercept for that one. So aside from like what we learned today, it was like the opposite of the symbols, if you remember. But here's like why it's really that. The definition of x-intercept is when what happens? For everything that's considered an x-intercept, that's when what happens? Look at my coordinates, maybe that'll tell you. That's when the y equals 0. So if this was my equation and I plugged in for the y a 0, and I went to like solve for x, well, I have 2 values for x, right? And in each parentheses, they're being multiplied together. Anytime you multiply and get 0, what must one of the numbers be? So even if you guys got this right, this is like super important. You'll see it later on, but this might help you better understand why it's the answer that it is. So I need your full attention, everyone, look at me, eye contact. I have this parentheses times another parentheses. I'm solving for my x-intercepts. That's when y is 0. Whenever I multiply and I get 0 as the answer, what's true about one of the things I multiplied? One of them would have to be 0. If I multiply to get 0, one of them would have to be 0. And there's actually 2 possibilities. It could be like this parentheses is 0, or this parentheses is 0. What would x have to be here to make this parentheses 0? It would have to be 7. So when x is 7, that makes a 0 there. But then it could also happen if x was what number? -3. Then it makes a 0 in that one. So that's why there's mostly 2 zeros in every situation for our quadratics, because there's 2 ways that you can make it multiply to get 0. Does that make a little more sense? I don't think it should matter the order that you write these. I'll check in a second. But that's why it happens to be the opposite sign. And then down here, you would have to either FOIL, box method it, or you could do like what I taught you. The y-intercept is when what happens? What's true about all y-intercepts? Something is your y-intercept when what happens? think back to the last unit that we did, when we had a table and we had numbers, this was on the test. Which one would have been my x-intercept? How did I know which one was my x or my y-intercept? It's when what is zero? When x is zero is for your y-intercept. So I don't know what's going on, you guys need to know that, that's a very thing that I try to say as often as possible. Your y-intercept is when x equals zero. So if I take that same equation, and now I just make the x is zero. What is 0 minus 7? What's 0 plus 3? What's -7 times 3? -21 is my y-intercept. That's the value for y when x is 0. You could also, again, FOIL this, do whatever you want. And then that single number in standard form is always your y-intercept. All right, I'm gonna just double check the key right now, so give me 1 second. But any questions on this one? Any questions on others? So it shouldn't matter the order that you put the x-intercept. Any other questions?